All right, I'm going to click start. Okay. Give everybody a few minutes to join us. Thanks to everybody who's joining us today. We're going to give everybody a few minutes to trickle in. If you want to say hi in the chat while we're getting started, let us know where you're calling in from. We always like to see where everybody's located. Also make note as you're going through, sometimes Zoom defaults the chat to hosts and panelists. So you might want to change to everybody if you want your message to go to the whole group. We've got one other person in Seattle. I'm also in Seattle. Some friends. Fani, you're in India.
Yep.
Remind me where in India you are?
I'm from Hyderabad, India.
Okay. Got at least some people here from late at night their time. Appreciate those people who are joining late. I'm gonna give it maybe 2 to 3 more minutes. Excuse me, I'm losing my voice today. 2 to 3 more minutes for people to filter in, and then we'll go ahead and get started. So people from Europe today, that's nice. All right, I think that we're tapering off, so I'll go ahead and kick it off. We may still have some folks joining as we come in, but I'm going to start just with a few housekeeping items. So first off, thank you to everybody who's joining us, especially if it's late in the day for you. We really appreciate you being here with us. I'm super excited for our topic today. Before we dive into that, excuse me, as I said, feel free to throw any comments, questions, etc. in the chat as we go through. You can also use the Q&A feature within Zoom for any questions that you have. We will be leaving some time at the end for Q&A, so make sure to take advantage of that. Also, we will have a recording of this afterwards, along with slides and materials that are covered, so those will be sent out to you. So you will get those shortly afterwards. And let's see, I think that's it. So with that, I'll go ahead and kick us off. Fortunately, since I'm clearly losing my voice, I am not going to be doing most of the talking today. I'm going to hand it off to my colleague, Pani Kumar, who has very graciously joined us from India very late at night, his time, to talk about Astronomer Providers. So Pani is a manager on our Airflow Providers team, and has done a lot of work architecting and developing these projects, and we're super lucky to have him here. So Pani, with that, I will give it over to you.
Yeah, thanks, Kenton. Glad to be meeting all of you here. So let me briefly introduce myself before we kick off the session. So I am Pani Kumar. I manage the Airflow Providers team in Astronomer. So I've been working on this project since the last 6 months, I would say, where we have worked on a lot of deferrable operators. So I think this is the best forum for me to talk more about our work, specifically on Astronomer Providers and deferrable operators in general. So with that being said, I will kick off the session. So please do let us know in case anyone has any question through the chat window that you have enabled. So we'll be glad to take up the questions meanwhile. So let me quickly share my screen. Hope my screen is visible to everyone. Please do let us know in case anyone has any issues in viewing the screen.
I think you're good.
Yeah, okay. So let me start the session today with a brief introduction about Async Operator. So there are two terms that I'm going to use interchangeably during this conversation. One is the word async, another one is deferrable. So both these terms are essentially equivalent to each other. So if we look at the history of operators and sensors, right? So the typical airflow operators or the standard airflow operators and sensors, whenever they run, they essentially take up a full worker slot. Say, for example, if I have an airflow instance where I have, say, 100 worker slots, and I have 100 DACs waiting to be run on that airflow instance. And say there is one sensor on which all these 100 DACs are waiting to run. So essentially, I cannot run anything else on that airflow instance because the sensor will be essentially waiting for some external event to happen, and essentially this airflow instance is in a way where I cannot run anything on that instance, right? So essentially the reason is because all the worker slots have been occupied across the airflow instance, and the issue is that the worker slots are not released whenever I need them to run other DACs, because we are essentially waiting for the sensor to be completed successfully so that other operators on the other DACs can be run. So this is where we can, in these sort of situations where there is an entire worker slot occupied, and in the sense that it is occupied, the reason is essentially if the worker slot is occupied, the resources are totally working towards, or the resources are being awaited in that airflow instance to pick up the other operators, to pick up the other tasks across the airflow instance, right? So this is where the async concept will come in. And an async operator basically is an operator that runs using the async IO library within Python. And it starts off the execution as a normal airflow operator, but the additional functionality that we get with this async operator is that while there is a blocking operation on this operator, right? So we can release the resources and ensure that other operators or sensors can pick up those resources. So in essence, that is the functionality of an async or a deferrable operator. Now, how could an async operator do that? So the functionality essentially is that the async operator can defer itself during the execution phase. And whenever it differs, right? So the execution actually happens, or the polling actually happens within a triggerer instance within that airflow instance. So essentially, we are releasing the worker from the task, and we are asking or polling the triggerer to check the status of the task. And once the task is done, on the triggerer side, there will be a signal sent back to the operator saying that the task is executed. So if you could see this diagram, right? So essentially, there will be an operator kickoff. The actual execution gets kicked off on the operator, but immediately after it gets kicked off, there will be a unique ID generated at the operator side, using which we will poll the status on the triggerer. And once the status is completed, we will send the event signal back to the operator. So this in essence is how an async or a deferrable operator will work, right? So let us go into further depth on what an async operator is in my next slide, and what are the advantages of using such behavior, right? So delving into deeper depth on this functionality, right? So assume that I have a Spark job which is submitted to an EMR cluster, say on AWS, right? So the Spark job will be doing its job, right? So on Airflow side, while the Spark job is running, there is no need for me to keep my worker slot occupied, right? Because essentially the operation is happening on the Spark job, and Airflow workers need not wait till the Spark job completes its operation. Essentially, I should be able to, in order to have more efficient utilization of the resources, I should be able to release the worker slot, poll the job for the status, and then once the status of the job is done, I can send an event back to the worker slot saying that the job execution is done. So essentially, most of the work, if you see on the async operator side, most of the work where we are awaiting for the process to be done is happening on the triggerer rather than the worker. So since we are releasing out the worker slot here, there is a possibility that such a worker slot could be taken up by other processes on my Airflow instance, which are waiting for resources, right? So that is where the efficient utilization of resources will come in, right? Am I clear till this point, or you have any questions? Let me take up the questions. Yeah, so essentially to answer the question on the trigger process, we could have multiple triggerers running on my Airflow instance. It's not just a single triggerer instance. I can have multiple triggerers being spinned up on my Airflow instances, and the load on the triggerer could be essentially distributed across the triggerers rather than doing the same job in the worker slot. Okay. So let us discuss briefly about the resource saving aspect of a async operator or a sensor. So if we go back to the history of Airflow, the Deferrable Operator framework was released in Airflow 2.2. Okay. Smart sensors were indeed added to Airflow 2.0 as an experimental feature by Airbnb, and whatever deferrable operators I'm talking now are a sort of generalized implementation which could be implemented across multiple Airflow operators, right? So we did a bit of research on the advantages of using async operators. So we did this experiment with the file sensor, the standard file sensor, and the asynchronous file sensor async. So you could see that there is a huge improvement in terms of the worker slots being released, right? So whenever the task is getting executed on, you can see that there's an improvement of 97.8% when there was a sleep before even starting the worker slot, because essentially you could observe that the more amount of sleep we had while we were waiting for the files to come in on the file sensor part, you could see that the number of slot seconds have drastically reduced, and there was a lot of improvement in terms of both execution times and the occupation times of the slots. You can see that the amount of seconds the slot was occupied, or the slot seconds, were much lesser on the async execution, leading to an improvement of more than 90%. So thereby, this results in two things. Essentially, I could manage running my DAX with lesser amount of resources than what could be possible with a normal synchronous version of the operators, right? And I could achieve more throughput and more concurrency and more efficient execution of task runs with this asynchronous or deferrable operators and sensor. So this was an experiment that we did recently on 1,000 task DAG run. So okay, coming back to the efficiency of the execution, right? You can see that in seconds, if we compare a normal sensor to an async sensor, you can observe that an asynchronous sensor took very less time here in terms of slot seconds compared to the normal execution time of a synchronous version of operator of a sensor. Essentially, this is the same sensor we tried running and comparing the slot seconds for both the sync version and the async version. So you could very well see that the amount of slot seconds which have been taken by the async implementation is quite less compared to the synchronous implementation of the same sensor. Okay. Now, let us briefly discuss about under what criteria should we be creating an async operator, or what would be the principle of creating an async operator. So basically two things. One is that whatever operator, say for example, if we take a BigQuery create empty table operator, what this operator does is it just creates a table in the BigQuery. So table creation is something which takes very less time rather than a query execution. Sometimes you can have a query which runs for a very long time, right? On a typical data warehouse or a BigQuery, you can have a job running for a lot of time compared to a detailed execution part. So essentially, in order to realize the gains of an async operator, we should try building an async operator for jobs which usually take a bit of time. It can also take some hours, usually for some of the applications, but the typical use case is that the job should run for a long time. Then only we will realize the usefulness of async operator. And there is one more criteria. And the criteria is that the async operator that we are building should allow us to do some level of polling. I will explain to you in further detail why we need to be able to do some polling, because the moment a job is inserted, the control is released from the worker, right? So the control is released from the worker, and we need to know the status of that job on the triggerer. Now, in order for the triggerer to know what is the status of that job, we will need a query ID or a job ID, which is generated by the API, right? So essentially, these are the two important principles which we need to keep in mind before even trying to build an async operator. Now, what are the typical use cases for building an async operator, or where would an async operator be useful? So in case there is a file system based operation, this file system based operation, for example, happens outside my Airflow instance, right? So if there is a file download or a file read and write, or if there is a network based operation, or if there's a database based operation or a data warehouse based operation where essentially the use case is like we are waiting for a lot of time for the operation to complete, and that waiting is not carried out inside Airflow, in the sense that I'm executing a database query, but the query is essentially being executed on the database rather than in the Airflow instance, right? So there's no need for Airflow to wait for such an operation to complete, where it could very well do some other operation while the blocking operation is being executed, correct? And also poke operations. These poke operations will usually come into play in sensors, as you might already be knowing that we do poke for a particular file to appear. Say, for example, if I take an S3 file sensor or S3 prefix sensor, we essentially wait for a particular file or a particular file to arrive in my S3 bucket, right? So these are the kind of operations where async operator or a sensor would be the most useful. So based on our research, we find that these are the typical use cases where an async operator would be very, very useful for saving on resources and money, of course. Right. Now, introducing to all of you this repository called Astronomer Providers. It is an open source repository where we are continuously building asynchronous operators and sensors, for which there are standard operators and sensors available on Airflow side, but we are building a corresponding asynchronous operator and sensor wherever applicable. So let me briefly go through the repository once. So this is the repository where which is the storehouse of all the providers that we are currently building, asynchronous providers. So So we currently have providers or deferrable operators on all these provider packages. The file structure would be similar to what we have in Airflow. Say, for example, if I take the Google provider, I have Google Cloud operators, hooks, and sensors being available in this repository. So there is a very simple installation process that we have come up with for installing the Astronomer Providers repository. So you could just do a pip install Astronomer Providers on your Airflow instance. But if you want to have a specific provider package to be available on your Airflow instance, you could very well install it using the extra, by mentioning the extra there. So at the moment, we have asynchronous providers available for all the packages that I'm showing you on my screen. So one typical use case is what would happen to my DAG. Say, for example, I plan to use an asynchronous operator or a sensor. Now, what will be the DAG facing changes that I might need? So essentially, nothing I would say, because other than the import statement on the DAG, there won't be any other change needed. In terms of the DAG facing changes, there should not be any other change other than changing the import statement. Okay. So in addition to the DAG facing changes, I would like to briefly describe about the pre-commit configuration that we currently have. So essentially, most of this repository contains a variety of pre-commit hooks, which would enable a developer to commit a good quality of code in terms of, say, for example, I have a Python linter called Flake8, right? So we have included it as part of the pre-commit hooks so that the Python code linting will be appropriate. We have a code spell. Say, for example, if someone introduces a typo, it won't allow them to, check in the code into the repository because we have a code spell pre-commit hook available in the repo. And if we are using YAML files within the repo, then I could check the YAML syntax well before I even merge the code into the main branch. So these are the pre-commit hooks, and we maintain all the recent providers that we have introduced in the change log. You can see that in the latest release, we have come up with 5 async sensors, out of which the more recent one are based out of Azure and also Hive, right? So let's go back to the deck. Okay. So the latest release of asynchronous providers, it contains nearly 35 operators and sensors. We have 30 pre-commit hooks, of which I briefly described. The checks are like we have a MyPy check, a Flake8 check, and so on and so forth. We have a code coverage of 97% on the repository at the moment, where we are ensuring that all the code that we write is properly covered with unit tests, and we are using marking libraries to ensure that the services are mocked and to ensure that we have a good code coverage. And one more good use case of this Astronomer Providers repository is that the DAGs that we are building are currently being used for our system tests, in the sense that we have a self-sufficient DAG being built, in the sense that if I have a BigQuery or say a Spark or a Hive-based sensor or an operator, we do all the pre-initialization steps. Say, for example, if I want to run a Hive sensor on AWS, say, for example. So what would be the immediate need or the prerequisites will be like, I need to spin up an EMR cluster, and on top of the EMR cluster, I need to have a Hive running on the EMR cluster, and then I should be able to connect from Airflow to that Hive instance and then execute the sensor and then shut down the EMR cluster, right? So these will be the typical steps or the entire workflow of running the Hive sensor. Now, we have ensured that all these steps are programmatically integrated within the integration test. So each DAG should be able to be directly consumed by the users. There should not be any need to, add additional logic to integrate it into the respective environment. So that way we have built a self-sufficient DAG. And one more important highlight is on the docs. So for any open source project, the documentation aspect is very, very important. So let me briefly show you the documentation that is available for the repo. So we have come up with a documentation using Sphinx tool, which is the Python auto documentation generator. So the readthedocs.io, this is the website that that it is currently hosted on all the documentation. So you should be able to go through the API reference on readthedocs.io, and the link is available here so that you can click through and see what is the functionality for each sensor and operator, async sensor and operator that we are currently building on. And yeah. Okay, so let me briefly take you through the typical structure of an async operator before I do an actual demo of the async operator. So any async operator that we are building should essentially have a structure where I have an execute and an execute complete method, right? So you can see that there are two methods here in this class. One is an execute method and another one is execute complete method. So what does that execute method do? The execute method essentially fires the task on the worker. That's the first step. And once it fires the task or task on the worker, it will take the unique job ID for the task, and then it will defer it onto the triggerer. So you can see that this example shows that I'm doing a self.defer, which raises a task deferred exception, and it will move the execution onto the triggerer. So this is the typical structure. Now, what happens inside the trigger? How does an execute work? How does an execute complete work? I will describe it as part of the demo. Okay. So I have created this DAG earlier today. So essentially on my local Airflow instance, I have a BigQuery DAG. And it's a sort of self-sufficient DAG because for running a BigQuery job on any BigQuery instance, I will need a data set to be available. And within the day, after the data set is available, I will need to create a table. Okay. And after the table is created, I'm doing an insert query on that table using the BigQuery async insert job operator. And I'm also executing a templated query on this using the select query job task. And then this is where you will observe the difference. So there are two tasks here. One is called an execute long running query sync, and the other one is called execute long running query async. Now, what's the difference between these two? Let me show you the DAG code. So at the beginning of this presentation, I was mentioning that there shouldn't be much DAG facing changes other than changing the import statements, right? So you can see the difference here. So in this example, I'm using an async version of BigQuery insert job operator, right? So I have changed the import statement where I'm using the import from the Astronomer Providers repository, and I'm using an async version of the operator. And I'm also using an insert job operator here, which is sort of taking the Airflow import, the standard Airflow operator. This is an example of the standard Airflow operator, right? So there are some environment variables that I'm creating here for the purpose of connection. And I'm creating a data set using the create empty data set operator. As I mentioned earlier, there won't be any need to create any async version for create data set or a create empty table, because these operations don't take much time in real-time scenarios, right? But an async insert job operator async, the reason I'm using an async version here is typically in production scenarios, there might be use cases where I'm doing a huge bulk insert onto my BigQuery table, and that might run for a couple of hours, right? So that is the reason I'm using an async version of insert job operator here. And in order to demo the difference between sync and async version, I'm executing the same long running query using the insert job operator first, and then the same query I'm executing using insert job operator async first, so that I can demo the differing functionality here. So let's go back to the DAG. So let me show you what is happening on the triggerer while the job is running. So let's observe it while the insert query job is running. You should see some information on the triggerer now once the job starts kicking off. So you can see that it started picking the execution on the triggerer once the insert query job is running. You can see that it will get deferred. Right. So this is where the sync operation is running. So you can see that the async version was used on the select query job, and hence it got deferred. So you can see that the sync version of the operator is running, and hence it keeps the worker slot occupied. You can see that with the color green. Yes, Karthikeyan, I'll get back to your question. Please give me a moment. So essentially this long running query runs for 1 minute. So throughout the course of that 1 minute, the worker slot will get occupied. You can see that in the green color. Right. So once that 1 minute is over, we can see the execution of the async task. I think it has, yeah. So let's see the async. You can see that the async got kicked off now. You can see that it started pulling on the triggerer, and instead of actually executing the query, it fired the query, and then using that query ID, we are polling on the triggerer to see what is happening. You can see that the log is saying that the query is still running and we are sleeping for 4 seconds, and so on and so forth. Essentially, it will loop in through 15 times because I have introduced a wait of 1 minute, which is essentially 15 times into 4 seconds. So you can see that it is in violet color because it got deferred. So the worker slot got released, and it is polling for the status on the triggerer. And once the triggerer polling is done, where it finds out that the query has got executed successfully, it will indicate to the worker, and then the task will be a success.
Funny, we have one question that I think would be relevant to answer now. Yeah. So just to clarify, when you say a slot is released, can you give more details on what that slot is? One was asking, is that like a worker slot versus a pool slot related to CPU, something like that?
Yeah, this slot term is something which is used quite interchangeably. So what I meant is the CPU that is occupied by the worker, right? So essentially, when any task gets executed, there will be CPU time used for execution of the job, right? So whenever we have an external task being executed, in this scenario, the BigQuery query, since the actual execution happens on the BigQuery side, we are releasing the worker slot by deferring the execution onto the triggerer, so that the same worker slot could be utilized by other tasks or other DAGs within my Airflow instance. That is what I meant when I say the slot seconds are less utilized once an async operator or a sensor is used. Does it clarify the question?
Yeah, that's great. Thank you.
Yep. So you can see that the async operation got successfully executed. Let's go through the log. So you can see that I have sent, I'll go through the code quickly, but before that, I just wanted to show to everyone the logs that we are printing here. So the response that I got back from the API is job completed, and I'm marking it as success. And whatever execution actually happens, the logs for the running logs for that will be available on the triggerer. You can see that throughout the course of execution, for most of the time, it was waiting for that query to get executed. And it was polling onto the triggerer instead of the worker. Okay. So what have we observed in the demo, right? So one is the deferral leads to reduced resource consumption, because with the same amount of with the same number of workers, I could probably run more number of tasks, or if I can also go for a reduction in the number of workers, because in case I have a lot of tasks to execute, and most of these tasks are using third-party APIs like a database execution or a data warehouse execution, or if it is waiting for a file like the typical use case of a sensor, I can reduce the number of workers that are needed to run these tasks, right? So that is the reason an async or a deferrable operator will lead to reduced resource consumption. And one more advantage is resiliency against restart. Say, for example, during the execution of my job, due to some issue, there was a failure on the task, right? So while the task is being pulled onto the triggerer, what happens is the task will start from where it was left off instead of doing the whole work again and again. So this was an issue with the standard operators that we typically have. But in case of an asynchronous execution, the advantage is that it will just pick up from where it got failed. So there won't be any need of doing the same work over and over and again, right? So typically these scenarios will be like in case we have a deployment or an infrastructure issue, the triggerer will take up the work from where their earlier execution stopped, and there won't be need to, start the task from the beginning. Okay. Okay. So there are a couple of considerations that we'll need to consider when writing a deferrable or an async operator. So essentially, all the deferrable operators rely on async IO features. So async IO is like a concurrent programming paradigm where we use an async await syntax along with coroutines to, develop the operators. So since async IO has been stable from Python 3.7, we have ensured that we need to use Python 3.7 as the minimal version for working with the operators, the asynchronous operators. Okay. The other important point is whenever your Airflow is started, please ensure that you have at least one triggerer and one scheduler at the minimum, because triggerer is needed for the deferral. We need to poll the status using triggerer, right? So we'll need to ensure that we have at least one triggerer. And we also need to consider whether the official library supports async version. So in case of BigQuery insert job operator that I have demoed to you, the official BigQuery API supports asynchronous execution. So we can directly use the BigQuery API in that scenario. But in case the official vendor's API does not allow asynchronous execution, we need to find a third-party library. Say, for example, in case of AWS, the official Boto3 library does not support async operations. So we have used AI or Boto there. So essentially, we'll need to do some research to find out a third-party library which will support the asynchronous execution for that operator. Okay, and as we discussed earlier, the async version should be easily swappable, and there should be no need to execute or change the DAG much other than changing the import statement, right? And we should be differing within the operator, within the execute method. Once we kick off the process, we should defer it using a triggerer, right? And within the trigger code, wherever we have a blocking operation, it has to be an async API execution of a function. So let me show you this example using the BigQuery API. So this is an example of the asynchronous BigQuery insert job operator. So what are we doing here is we have an execute method that calls a BigQuery hook, and it retrieves a job ID. And using that job ID, you can see that I'm deferring it. I'm retrieving the job ID using the BigQuery hook. The BigQuery hook essentially calls the BigQuery API to retrieve a job ID, and we're storing it in self.job ID. And then we are deferring it using the self.defer here. And you can see that I'm passing the connection ID and the self.job ID here. And then what I'm saying is, after deferral, please execute complete method. So when the signal comes back from the insert job trigger, we'll execute the execute complete method. Okay. And execute complete method will indicate the status back to the worker. Okay. And let me show you the insert job trigger code. So what am I doing in the insert job trigger? Once I retrieve a job ID, what is happening inside this trigger? So every trigger should essentially contain or it should override the serialized method. And within the serialized method, I am returning a serialized instance of the BigQuery insert job trigger, along with the attributes that are needed for the trigger to run, which might be a connection ID, a job ID, a dataset ID, and so on and so forth. So these attributes might be different for different triggerers based on the use case, but we'll need to return a serialized instance of the triggerer on using the serialized method. And this is where all the magic happens, I would say. So within the run method, you can see that I'm returning an async iterator for a trigger event. So I'm getting an async version of the hook. And if you remember the statements that we had here, sleeping for 4 seconds, executing get stop status. This is from where I'm getting those logs, sleeping for 4 seconds, query is still running, right? So what am I doing here is I'm getting the job status using the past job ID. And if the job returns me a success status, I will yield a trigger event. Now, what this trigger event does is it will indicate to the worker that the job execution is done and the task can be marked as success. So that is the reason I have a yield here. And in case the job is still pending for execution, so I'm printing out logs on the triggerer saying query is still running. I'm sleeping for a pre-designated number of seconds. Okay, and I'm doing an async io.sleep till the query runs. So we'll sleep for 4 seconds for every execution or for every loop. We'll wait for 4 seconds, it will wake up, and then it will check whether the query got executed. Okay, If none of these scenarios are met, if it is neither s-axis nor if it is pending, I'm yielding an error here, right? So this is sort of error reporting where I'm sending back to the worker that it's a failure from the API side. But in case there is an exception during the execution of this whole code block, I'm raising an exception along with the trigger event of error. Okay. So let me show you the async hook. So every implementation of the asynchronous hook should essentially contain such an implementation what I am showing on the screen. So what am I doing here? So I have written a get job status method, okay? And it will just await for the job client, because job client might be a blocking operation. So I have tagged it with an await here. And then I'm again doing an await. Await means it will release the control back to the event loop that is present on the async IO side. So within the triggerer, we are releasing the control back to the event loop, which will help in picking up other tasks on the worker. So that is the reason we have an await here, and we are doing the operating system error handling here. In case there is an OS error, I am doing a job status of pending. It depends on case by case basis what exceptions we raise here. It depends on the API that we are using. Okay. And how are we getting the job output? Again, it's an async def coroutine where I'm opening a session, I'm getting the job instance, and I'm awaiting for the query results. At each and every stage, wherever there's a blocking operation, you can see that I have depended it with an await. So essentially, we are releasing the control back to the event loop here, which will help in picking up other tasks. Okay. So what are the limitations of a triggerer, right? So we have seen that we are leveraging a trigger instance and we need to initiate that trigger on the Airflow instance that we are using. But what can a trigger do and what can a trigger not do? So triggerer can receive information from the operator, because from the operator code, if you see, so this is the operator code. I'm passing the information of job ID from the operator code to the triggerer. So triggerer can receive information from the operator. That is what it means, right? And triggerer can send the information back to the operator. You can see through a trigger event, right? So there will be communication between an operator and a triggerer, but the actual work or the polling happens on the triggerer and not on the operator. So that is the important difference that we all need to keep in mind. Right. So just a call out that we need to use any async IO compatible library on the triggerer. If the vendor's API doesn't support it, we need to use a third party or an open source library, which will give us the synchronous capability, right? So any questions? I think I will open the forum now for questions. So let's discuss about the questions.
Yeah, thanks, Funny. That was great. Really in-depth overview. We do have a couple of additional questions that we haven't gotten to yet. The first is, how many deferrable tasks can a single trigger handle?
Can you come on the question again? Can you come again?
Yeah, so how many deferrable tasks can a single trigger manage? Or maybe put a different way, at what point would you look to run multiple triggers, or can you?
So as much as is allowed by the triggerer instance that you're configuring based on the resources that you allocate to the triggerer, because essentially there is no limitation. I can run innumerable number of processes on the triggerers, because every process that I'm running on the triggerer will have a query ID or a process ID associated with it. So there shouldn't be any issue in terms of execution per se, but the only limitation is based on the resources that we allocate to the triggerers. So essentially it's directly proportional to the amount of resources that we have, or amount of resources that we can allocate for the triggerer, I would say.
Got it. Thanks. And then our last question is, are the task states for deferred tasks still stored in the metastore? So related to how does the trigger pick back up after if there's a failure in the process?
So if there is a failure in the process, essentially that logic is already built into the core Airflow code, right? So let me show you that. So in case of an error scenario, right? So we are raising a trigger event back to the worker here, right? So essentially there will be a communication back to the worker node saying that the triggerer has failed to execute this particular task, and we are reporting the status of an error back to the operator. So if event status is an error, we are raising an Airflow exception event here. But in case of multiple triggerers, which will be normal in case of a production scenario, essentially there is no restriction that we should run only one triggerer instance on my production Airflow instance, right? I can have innumerable or multiple number of triggerers. So there should be no limitation there. And since the trigger, it polls based on the job ID, right? So using this job ID, for example, my triggerer will fail suddenly, but the job is still being executed in the background, right? So when the triggerer wakes up again, the triggerer will still use the job ID to know the status, correct? This unique process ID is something which will help the triggerer to pick up from where it has left. Not sure if that answers your question to whoever who raised that, but it essentially happens through the unique process ID or the job ID that we are using to execute that particular job on the triggerer.
Right, and just to repeat that back to you a little bit, sure I understand. So that's all part of the trigger's logic that is contained within it, is managing all of those processes. So you, as the user, you don't have to worry about any of that. Yep. Great. Well, we don't have any other questions up right now. We'll give everybody one more minute to throw any in there in case there's anything else. But otherwise, like I said, this was a really great presentation. Thanks for that in-depth dive into Astronomer Providers. Hopefully everybody will find a good use for them. And it doesn't look like we have any additional questions, so go ahead and give everybody a few minutes back. Thanks everybody so much for joining us. I will also throw out before we go a reminder that the Airflow Summit is next week. So you can join virtually, or there are some in-person meetups in certain cities. So highly recommend looking at the Summit website to see if there's any of those you want to go to in person or join virtually. There's going to be lots of really great talks, including, I believe, a couple on Astronomer Providers or Deferrable Operators. So if you want to learn more about this topic or any others, that's a great forum to do so. There'll be lots of great content there. So hope to see you next week. And thanks again, everybody, for joining.
Thank you.
Bye, everybody.